Alrighty, so in this problem, we want to find the indefinite integral of cosine of square root of x dx. Techniques I'm going to use are integration by substitution, illustrated here. If you have some function of another function times its derivative, it's just the integral of taking that function as a variable, right? Better illustrated over here. And integration by parts. If you have an integral of product of two functions, you just follow this formula right here. Alright, so I'm going to start off by writing my integral down. This is kind of a weird function to integrate. You might want to, first of all, find a nice substitution to make. I'm going to use the substitution u is equal to square root of x. The differential of u, or du, is the derivative of u of x times dx, right? The derivative of square root of x is just 1/2 times x to the minus 1/2, right? Which is equal to 1/2 square root of x. Sorry, and of course you multiply it by the dx. So then we get, if we multiply both sides by 2 square root of x, we get 2 square root of x du equals dx. But if you remember, square root of x is just u, right? So let's go back to our integral. U du, right? Substitute that for dx. And cos of square root of x is just cos of u, right? U cos of u du. Next thing I'm going to do, integration by parts, right? You have a product of two easily integrable functions. So I'm not going to use u and v, instead I'm going to use t and s because I already have a u sub. T is equal to u, dt equals du, ds equals to cosine of u du we need to integrate cosine of u to u, which is sine of u, right? S is equal to sine of u. So you want t times s, so 2u sine of u minus the integral of s dt. The integral of sine of u du. The integral of sine of u is minus cosine of u. We have two minuses, it becomes a plus. Oops. Plus a constant, of course. 2u sine u plus cos u plus c. Next, we just substitute u as square root of x in our equation, or expression, sorry. Oh, and this should also have a 2, sorry. The 2 goes through the entire integral. Oops. C is any arbitrary constant, and if you were to differentiate this function, you would get cosine of square root of x. Alright, that's it. Thanks for watching.